Welcome to this Wednesday's version of Webcast Wednesday. I am Rishi Iyer, an application engineer at National Instruments, and let's get right to it. So last week on Webcast Wednesday, my colleague Jagrati talked about timing operations, the timing palette, and the use of the various timing functions. At the end of last week's session, we had a small contest to generate a sine wave, and each time the values exceed a threshold value, which can be an input by the user, to change the color of the graph to indicate warning. So we'll just take a look at how we can implement this demonstration. So I have the code here with me. Let us just look at the code. It's a fairly simple code. Initially, we use an ExpressVI to simulate the sine signal. We are converting this from the dynamic data waveform right down to the numeric 1D array. We're giving this as an input for the count terminal for the for loop. We're also inputting through a control the threshold value which we want the user to indicate. And finally, using a case structure for a comparator, comparing the threshold value with the current sine value, which next using an index array, we either input the same waveform that we wanted to by splitting it into two parts, giving this waveform here, and secondly, if it is true, then we change the value of this array to not a number, and we input an additional array, the color of which we can change using the settings of the graph. Finally, an additional input that we have used is the threshold value. We have auto-indexed it to an array and also plotted it onto our graph using this function. Note that we are not concatenating the inputs here, but creating a 2D array. So if you just run the graph, run the VI, the graph shows us a threshold value 5 inputted by the user and a sine wave with a different color after the threshold. So I can change this threshold value to, let's say, 0, and if I run this, I'll get a sine wave with a different color above 0 and a different color below 0. So that was just a look at last week's contest. This week, we will look at linking external applications with LabVIEW through the use of ActiveX. So many of you might be familiar with ActiveX, but initially we'll just look at ActiveX on a conceptual level. We'll then use ActiveX for connectivity with LabVIEW in two different ways, and we'll talk about design and implementation of linking external applications with LabVIEW. So firstly, ActiveX is a software framework created by Microsoft. What it has enabled us to do is interact using various Windows-based applications, and ActiveX controls, they are the smaller programs. They're sometimes called add-ons, which can be used on the internet as well as on Windows-based applications. They enhance our user experience. They allow some sort of animation or help with performing certain tasks. What it also allows is for interaction between various applications. So we can use LabVIEW as an ActiveX client to access objects, properties, methods, or events associated with other ActiveX enabled applications. So LabVIEW will behave as a client which will be accessing the features of various different ActiveX enabled applications. LabVIEW can also interact as a server wherein other applications which are ActiveX enabled can access various LabVIEW VIs or objects or properties and methods. So on our block diagram, under the connectivity palette, we'll find the ActiveX sub-palette, and these are the various functions that you'll find on the ActiveX sub-palette. we'll be looking at a few of them in our application. So in order to use ActiveX, what we will do is create a reference to the server, that is by using a function called automation open, which gives us a reference to an ActiveX enabled applications server. So using that reference, we shall give that reference to property nodes or invoke nodes to operate on the server. So what are property nodes? Property nodes will be accessing certain properties of that server or object that we have placed. Invoke nodes will be invoking certain methods onto that object. Finally, after we have completed permutations and combinations of properties and invokes, we will close the reference to the server such that no half-open references are left lying around, and we will check for errors, which is an optional way to end our program. Firstly, let us look at ActiveX as an LabVIEW as an ActiveX client. We can open an application such as Microsoft Excel, in this case Microsoft Excel acting as a server, create a document and add data to the document, all in LabVIEW. Secondly, we can embed a document, in the first case Microsoft Excel, in this case Microsoft Word, on the front panel in a container. This is known as an ActiveX container and can be found on the front panel under the .NET and ActiveX subpalette. Thirdly, we can also place buttons or other objects from another application, such as a help button that calls the other application's help file on the front panel of our LabVIEW VI. These are the three examples of using LabVIEW as an ActiveX client, in which we will be accessing the different functionalities of ActiveX enabled applications in LabVIEW. Some of the software that allow us to do this is Microsoft Office for Word, Excel, PowerPoint, Access, etc. We also have media players which are ActiveX enabled, Adobe PDF readers. NI Test Stand is one of National Instruments software which interacts with LabVIEW using ActiveX. Mail clients, for example Outlook Express and IBM Lotus Notes. Web browsers, Internet Explorer being one example, and calendar applications. So we can use all of these in LabVIEW and connect with them using a certain LabVIEW functionality. Secondly, we look at LabVIEW as an ActiveX server. The LabVIEW application, VIs, control properties and other methods are available through ActiveX calls from other applications. In this case, the other application acting as a client. The ActiveX enabled applications can request for these from LabVIEW, and very similar to how we can embed an Excel spreadsheet in LabVIEW, we can embed a VI graph in the Excel spreadsheet using the ActiveX functionality. So we look at one such demonstration. So in this case, I am using an ActiveX container on the front panel to embed Windows Media Player onto our LabVIEW VI. This can be found in the control palette. Under .NET and ActiveX, we'll find Windows Media Player. We can also insert an ActiveX container and select various applications to be embedded on the front panel. I just need to right click on the ActiveX container, and if I say insert ActiveX object, I get a whole bunch of documents which I can embed onto my front panel. I also get controls. These are ActiveX controls that I can embed onto my front panel. And finally, I get to create objects from file. So we'll just look at this application here. If you were to go through the block diagram, it's a fairly simple block diagram. As mentioned in one of the previous slides, we have created a reference for Windows Media Player. This is done directly in this case by just dropping it into an ActiveX container. We take the reference to a property node in which we are putting in a constant constant for the URL, and we are wiring the same reference and asking the Windows Media Player embedded through an invoke node to play. So as you see, an invoke node here is being used to implement a method. And finally, we are closing this reference and running this in a while loop such that only after it plays once, it will stop. So if I were to show the front panel now and run this code, we are able to view the Windows Media Player directly on our LabVIEW front panel. In this case, we'll be able to use the functionality of Windows Media Player by playing, pausing, stopping, replaying, seeking through the video, changing the volume settings, just as we do in the normal Windows Media Player. We can also include multiple files to create a playlist. We can shuffle through playlist and add whatever functionality we see as fit for our application. Our second demonstration that we'll be seeing today is integrating Lotus Notes on LabVIEW. Users can try doing this with Windows-based applications for mail, so you can use your Outlook Express as well. We'll be looking at building this from scratch, so I'll be sharing my block diagram with you. Under the functions palette in connectivity, we have the ActiveX subpalette. Let us just pin this. The automation open, as we have discussed before, opens a reference to an ActiveX object. In this, I go ahead to select an ActiveX class. So just as we saw the ActiveX container, we'll get an option to access various servers. So these are the various objects that are available to me. In this, I shall look at Lotus Domino objects, and in Lotus Domino objects, I will look to open a reference to a session. As you see, this appears on my front panel as well as a control reference. Once I've opened a session, I will look to initialize that session. So I give the reference of the session and to an invoke node, and this invoke node I use initialize. So in order to initialize the Lotus Notes which is present on my computer, it will require me to input a password. So I will create this as a user control and make this a password display. Now I will, for a multi-purpose internet mail extension, it will ask me whether I would want to enable it. This would be a property node. So this is something that I will need to do in order to access my database. So it will ask me whether I want to convert my multi-purpose internet mail extension. I will give this default value as a false. Now I will drop an invoke node onto my block diagram. Here I'm wiring the error clusters such that I have a certain path the data flow should be maintained. This invoke node I will use to access my directory, my database directory from the session, I will be required to give a default value. So I give a default value to the P server. I'll drop another invoke node to access from my database directory. So I'm using the reference of the database directory now and not the reference of the session anymore. So from my session, I've opened my database directory. I will use the control reference of the database directory to invoke a method on the directory. This method, I will say open mail database. Now, as you see, I have a new reference for my open mail database. I'll use the error cluster here again. I will now create another invoke node, use the reference of the open mail database to invoke a method on the email. Here I say create document. So I have created a new document. I will add another method using in the document. I will need to replace item value. Now this item value is the user to whom I want to send my email to. So here I will write send to, and I will use a string input to take in the to address from the user. So whatever the user inputs here, that will be the address to which this send to will be relocated. And finally, I will use an invoke node for this document and use a method saying send. In the send, again, I will need to create default values. So I will use the same input here. After I have done all this, it would be good practice for me to close these references. So I'll close this reference here. This reference was the database reference needs to be closed as well. So I'll close this here. Before the database reference, we had a directory reference, and we also had the final session reference. Once I'm done with my programming, it will ask me to input my password here. I could create this into a dialog box as well. So without access to my password, it will not be able to send emails from this client. We can also configure it to ask for a username and password and look on an internet. Finally, a to address needs to be mentioned. So I will mention my own email ID. And once we're done with this input, we can run this program. So this program has been run once. We can check the email inbox, and here we have at 4:24 an email sent. An email sent to my inbox. As we have not mentioned any subject or body of the mail, this appears to be an empty mail. We can include signatures and other functionality as well on this email. This VI can be used in multiple places. Let's say you're on the shop floor and you want to send a VI report to your colleagues, you want to share it with your colleagues, you can do it directly using LabVIEW. This is one of the multiple applications that you can think of for this demonstration. So the contest of the week is now live on labviewEnable.in. The contest of the week for this week is to modify the mail client VI, which was demonstrated just now, to include the following functionality: a subject, a body, and to send a copy of every mail to yourself. Now, a small hint: for the first two subparts of this contest, you will require to use additional property or invoke nodes in the same way that we have demonstrated. And finally, the third subpart would be modifying the to column a little bit. So we could maybe make it an array or include a few constants in case you want it to be sent definitely to yourself. The link of this question is now available on your chat box. You can access it from there. Last week's winner is the user with NI community user profile Manish26. Many congratulations to you. You will receive a personal message, and please await that personal message in your inbox. You will be receiving 50% discount in CLAD. The answers of previous week's Webcast Wednesday have been updated in the session.